Hello chemists, in this video we're going to take a look at something called the combined gas law. And the combined gas law combines several different laws. Charles' law, Boyle's law, Avogadro's law. And in my class I'm not a big fan of memorizing names and I just like to put it all together. So the equation itself looks like this. We have pressure times volume over temperature equals pressure times volume over temperature. And we have initial and we have final. So we'll go 1, 1, 1, 2, 2, 2, like this. Now what sometimes gets left out of this equation is number of moles, and that would go here. And the number of moles gets left out because, just kind of a quirk in mathematics, if you have the same amount on both sides of an equation, they cancel out. And oftentimes in these types of equations, where we have pressure, volume, and temperature, imagine you're filling up a balloon at a certain pressure, volume, and temperature, and that balloon, you change something about it. Maybe you change the temperature, maybe you change the pressure. But when you do that, the amount of air, the number of molecules inside of the balloon doesn't change. And because it's the same before and after, it cancels out. And so the equation often doesn't have the number of moles in it. Now in this equation, we have to use certain units in order for it to work properly. And the units for this is pressure is in atmospheres, volume is in liters, and temperature is in kelvins. And we might not be familiar with kelvins as a unit, but it's kind of important because in this equation, if we divide by 0, and we can get 0 on the temperature scale in Celsius and Fahrenheit, if we divide by 0, then our math doesn't work out so well. So we're going to have to do a conversion and convert Celsius or Fahrenheit into kelvins. And some other common conversions here. With atmospheres, well, in atmospheres, pressure is often measured in millimeters of mercury or in torr. And so millimeters of mercury or torr Now, a millimeter of mercury and a torr is really the same thing. And as it turns out, there's 760 millimeters of mercury or 760 torr to 1 atmosphere. So I'm just going to put a 760 here. So it goes 760 millimeters of mercury is equal to 1 atmosphere. And the other conversion that we often run into is milliliters and cubic centimeters for volume. So I'm going to say here 1,000 milliliters, which is the same thing as a cubic centimeter, is equal to a liter. So we might get our units in milliliters or in centimeters cubed, and we can convert that into liters. And then temperature here, temperature, the conversion for that is a Kelvin is equal to a degree Celsius plus 273. Now that we've introduced the combined gas law, let's try doing a practice problem. So here we have a sample of oxygen gas at 380 millimeters of mercury, and it occupies a volume of 10 liters at 0 degrees Celsius. What is the pressure of the gas at 15 liters and 25 degrees? So right away, as I look at this, I can see that my pressure I'm going to have to convert. My volume looks okay. But then my temperature is also in Celsius, and I'm going to have to convert that over. So I have to do some conversions here, and I'll just start with my 380 millimeters of mercury. So I'll start out with 380 millimeters of mercury. And I will have to convert that. And I know that there's 1 atmosphere per 760 millimeters mercury. So that gives me 0.50 atmospheres. So now I've got my pressure there. And the next thing is my temperature. Now my temperature, I just need to add 273 to it. So 0 degrees plus 273 would be 273. I'm going to go 273 Kelvin. And then 25 degrees Celsius, if I add 273 to that, that will end up being 298. So I'm going to say 298 Kelvin. And now I can start plugging things into my equation here. And remember, I have before and I have after. And when I'm done, I want to figure out what is the pressure. So I think I want to find this here. What is the pressure when I'm all done? Now, just plugging in numbers here. Let's see. I'm going to have, starting out with my half an atmosphere. So I'm going to go 0.50 atmospheres. That will be times my volume, and my volume is 10.0 liters. All of that is going to be over my temperature, which is 273 Kelvin. And now I need to make a little bit of space here. So let's just, my pressure, and that is times my new volume, which is 15.0 liters. And that's over my new temperature, which is 298 Kelvin. Now, to solve for pressure here, I'm going to have to multiply both sides by 278 and divide both sides by 15 liters. That gets rid of my 15 and my 298. And I'm left with just my pressure here. And when I did all of this, I ended up with my pressure equaling 0.3639 atmospheres. And we might round that to 3 sig figs here perhaps, so be 0.364 atmospheres. Now, what I would encourage you to do is, I did all this math here on the board. I would try setting this up and then typing it into your calculator and make sure that you come up with this answer here. Everybody's calculator is different. You want to just make sure that you get the right answer when it comes time to doing homework and taking exams.